Okay, this is going to be a fairly short video. Occasionally I get questions. People that want to start working on radios, and sometimes the specifications or the measurement levels in service manuals can be confusing for people. I used to be a confused person. Not gonna lie to you. I was definitely one of the confused at one point in time. And what causes that confusion is the calibration standard for an S meter. For starters, there's two different standards. Actually, let me grab my little charts over here. So when you do a transceiver alignment, you have to of course calibrate your S meter. And a question I occasionally get asked, and it's a question I used to ask myself, was, what do I calibrate it to? Some service manuals say 50 microvolts, others say 100 microvolts. Some are a little bit more specific in how that 50 or 100 microvolts, there might be some words after that, and those words that are after that are very important. So for starters, like I say, there are two different standards. So you have a set of standards for up to 30 megahertz, and then another set or another calibration standard for frequencies above 30 megahertz. So I have two little charts. I just keep these handy, print them off, get them online. There's lots of different people that have made these things. I just happen to really like this one. It has a lot of the important stuff that I need to know. But the common question, let me just move the camera down here a little bit. Common question I get asked a lot is, actually this zoom down to this a little bit. So for starters, like I say, there's two. Oh, this damn mat is so sticky. Lay something down on it, I can't pick it up. Thank God for fingernails. So you can see there's two different ones. Frequencies below 30 and frequencies above 30 megahertz. But I've been asked, and it's something, like I say, I've seen. Is it 50 or 100 microvolts for S9? So if you watch my videos, there's a good chance you own or have CB radios, and that might be what you're asking about. This one here is going to be for ham operators. Now, of course, below 30 is the HF band, so of course very common for hams too, but this one's definitely not CB. So if you have a CB radio, the standard, like I say, is very frequently set at 100 microvolts. That's what you'll see in service literature. But then you'll see other service literature that says 50 microvolts. So which one is correct? And that's one of the reasons I don't like the standards when they're given in microvolts. I really wish they would give it in decibels or dBm. The reason is there's two different ways of measuring voltage. Under load or not loaded. So you can see here we have relative intensity, received voltage, received power, and then you also see on this one I've handwritten in microvolts EMF. EMF stands for electromotive force. So the standard for S9, which is what you would normally calibrate when you do the calibration of your S meter, that's what they'll tell you. 50 microvolts for S9. So you set your signal generator to 50 microvolts. If it's AM, it'll usually be modulated at 30%, and then you adjust so your meter reads S9. But it's 50 microvolts, which is 34 dBUV, or 50 picowatts. Yeah, it's really small because you start micro, pico, femto, and hell, I can't even remember what the hell the A is. What is that? Alto watts? Not altoids. I think it's alto watts. But anyhow, dBm would be minus 73 dBm. But this little handwritten column here, you'll notice that says, and that's, remember, microvolts EMF. That's 100 microvolts. That's what's confusing for people. Which one is it? Is it 100 or is it 50 microvolts? Well, as you can see on this chart here, the answer is yes. And the answer is yes to both of them. It is 50 and it is 100 microvolts. The difference is this measurement here is with no load. This is with 50 ohm load. That's the difference. Now, if we look at the communications test set here, this one actually demonstrates that very well. And it does all of these different measurement types. So I currently have this set up at 28 megahertz. This meter right here is the actual output level coming out of this coax cable right here. Okay, and you'll see that's, you have to come in a little bit closer, you can see that it actually says microvolts. Okay, little UV lit up there. But if you notice down here, there's a little LED lit, and right above that it says into 50 ohms. And if you look over here, there's another little LED that's not lit that says EMF. Now watch this meter. Actually, it's the analog and digital meter. They're both measuring the same thing. It's one of the reasons I like this communications test set. It has an analog in addition to the digital meters. But watch what happens when I switch this over to EMF. Aha! It's 100 microvolts. Now, it's still putting out the same thing. So if we come back out here, so you can see, here's the cable, goes over into the spectrum analyzer there. So no funny stuff going on here. And watch what happens when I switch from EMF to into 50 ohms. The output is still exactly the same. So if you watch that peak on the spectrum analyzer, it's not going to change. So there's EMF, there's into 50 ohms, EMF, into 50 ohms. Notice that the level never changed. And I'll show you that it's definitely coming out of this signal generator. So we'll change it to, let's say, 1 millivolt. So there's 1 millivolt into 50 ohms, or 2 millivolts EMF. So I had to move the camera back over this way a little bit more so you can see 2 millivolts EMF, 1 millivolt into 50 ohms. But the level has never changed there. That's what's confusing. So when you're looking at the standards, that's one of the nice things about having these. You can also, if you print one of these things out, you go online. Like I say, there's lots of different people who have made these. They're available to download. I just like this one because it has all of them. I mean, granted, it didn't have that standard. I wrote that in. But I think that's a big problem with CB manuals or CB service manuals. Most service manuals have that blasted listing for the calibration of the S meter in EMF, but it doesn't tell you that. It just says 100 microvolts, leaving you to wonder, is that 100 microvolts into 50 ohms, or is that 100 microvolts EMF? If it's 100 microvolts, they're talking about EMF. So you just need to watch that, and you also need to know your test equipment. You need to look up if it's not, like in the case of this one where it's printed on there and has indications. You may need to actually just look it up in the specifications, literature for your signal generator to see. When it says it's putting out, in this case, 1 millivolt, is that 1 millivolt into 50 ohms, or is that, EMF? Because that's actually 2 millivolts. So just be aware of that. The main reason I like dBm, now if you work on ham radios, you look in service manuals for ham radios, I can pretty much guarantee you all of those are going to have the standards listed in dBm. So that would be this column here. Now this is the decibels is logarithmic. So yeah, it's a little bit of math involved, but once you get used to the numbering system here, it just becomes a lot more clear, and especially if you're doing power measurements, decibels is actually easier to use, especially when you're looking at stuff on like a spectrum analyzer, because you can view tiny little signals in the presence of gigantic signals. So you could have 1,000 or 10,000 watts, and of course not directly into the spectrum analyzer, you'd have to go through an attenuator, but on the same scale you'd be able to view a 10,000 watt signal and a 1 microvolt signal, let's say, and still be able to see both of those on the same scale. It's because it's logarithmic. So if I actually grab another chart, yeah, it's always lots of charts involved when you do this kind of stuff. So you can see here, like 1 kilowatt. Again, I had to add in because the chart didn't go up that high, but 1 kilowatt is 60 dBm. But if you notice, if you go down, let's say to, I don't know, let's say 1 watt. Where is 1 watt? 1 watt's right here. Well, that's only 30 dBm. So the difference between 1 watt, right there, and 1 kilowatt is only 30. And you can even come over, you can come down to milliwatts, microwatts, yeah, how this goes down into, I guess that's what the down to femto watts. So, but like I said, it keeps the grid, because it's logarithmic. It's basically kind of keeps it compressed down, so it's easy to view two massively different signals on the same screen or on the same piece of graph paper or something. So decibels. One of the main reasons I like it is, so like I say, this will measure in microvolts, millivolts, any of the voltage measurements, but I can also do dBu, which you can find that written in two ways. If you look at this chart, it's actually dBuV. So I can switch that. So if you watch the meter over here, you'll see that change. So if I switch to dBu, so that's dBuV actually. Basically the same thing here. They just don't use the V. A lot of standards, a lot of times you'll see that the voltage or the V will be missing. But I don't like that one, because if you notice down here, we have this nice little indicator light, and the camera went out of focus. What the heck, camera? Hocus pocus focus. There we go. Into 50 ohms, but notice that if I change the EMF, it changed. It allows me to change it. That's because measuring dBuV, you again need to know, is it into 50 ohms or is it just EMF? I prefer dBm, so if we switch to dBm, you can see, actually we'll do what would be the normal, for like a CB radio. S9 is minus 73 dBm, so we'll go minus 73 dBm. So you can see that's what the signal generator is putting out right now. And switch over to microvolts. Now it's 50.1, because a lot of times these little charts, they won't have a lot of the decimal point stuff here, just to keep the chart simple. But yeah, there is a slight little difference. And we'll switch over here to EMF, so you can see, yep, that's 100 microvolts. And we can switch back over to dBm again. See, that's minus 73 dBm. Now, the reason I like dBm, that measurement standard is always into 50 ohms. If you watch what happens when I push this button, it beeped. It will not let me switch it into EMF. dBm is always into 50 ohms, so there's no confusion. If it's dBm, it's always into 50 ohms. So that's another reason to use dBm. You don't have to worry about getting confused. Is it dBm EMF or dBm into 50 ohms? You don't have a choice. If it's a dBm measurement, it's always into 50 ohms. And you look at the spectrum analyzer there again, you can see nothing changes. The level never changes. I can switch from minus 73 dBm, which is 34 dBu, into 50 ohms, which is 40 dBu EMF, which is 100 microvolts EMF, which is 50 microvolts into 50 ohms. Yeah, a lot of standards all mean exactly the same thing. All of those level measurements. So I just wanted to show that, because I think that's the really confusing thing. Is it 50 or 100? 50 or 100? The answer, like I say, it's yes. It's both. One is an electromotive force measurement with no load. The other one is into the 50 ohm load. So just keep that in mind when you're doing S-meter calibrations, and I hope that kind of clears it up. Like I say, the proof is in the pudding, because if you look at the spectrum analyzer, there's 100 microvolts, there's 50 microvolts, but the spectrum analyzer never changed. I have that measuring microvolts, but that's microvolts into 50 ohms, so it's showing 50 microvolts as the level. Doesn't matter what this one here says. So I hope that straightens that out a little bit. So if you work on radios, when you see 100 microvolts in service literature, especially for CB radios, that's an EMF measurement. There's a really good chance, if you're actually getting into doing transceiver alignments, very, very good chance your signal generator could be either one. Matter of fact, we can even show that. So we'll actually disconnect from this one. Easiest thing would be actually for me to just put an adapter here. give me a second. Let's see, what do I need? UHF, BNC, male. And this is going to add a little bit more inaccuracy to it, all these extra adapters, but just make it be a lot faster for hooking up. So, what I just did, I just connected the spectrum analyzer to the B&K 2040 CB signal generator. So, I'm going to turn that on. Of course, I'm going to have to change, let's see, frequency 27, let's go to 185 megahertz. That on channel 19. And turn modulation off. Okay. Let's see, amplitude, or no, actually I want peak. Okay. And I don't have, wrong scale here. Oh, help if I turn that off too. Okay. So there I have, that signal generator is now putting out 100 microvolts. You can see the spectrum analyzer, it's 50 microvolts. So that's the output on that one, the meter. Actually the attenuator, the knob right there, and that meter, they're calibrated in EMF, which is what most CB service manuals are. And that's probably why they did that when they designed that. They made that one, the output, calibrated in EMF because they knew most CB service manuals, that's what the specification they're putting. So, but that's one of those things. I have to be aware of that. When I'm using that signal generator, if I'm using that for my frequency, or for my signal source, I have to make sure that when I'm calibrating a meter for S9, and the manual says 100 microvolts, on that signal generator, that's exactly what I would set it to. 100 microvolts, and what I will end up with is 50 microvolts into 50 ohms, or 100 microvolts EMF. If I am using this one, I just need to pay attention to this little red light here, whether I have it set to EMF or into 50 ohms. So that's where it can be confusing, especially if you have more than one piece of test equipment. One might be calibrated into 50 ohms, the other one might be calibrated EMF, so just be aware of that. Now granted, it's not the end of the world if you don't get your S-meter calibration correct, but other than maybe an unhappy customer, but that's just one of those things to be aware of. So I hope that helped to, straighten that out for some people. Like I said, I know that can be confusing. At one point, I had no clue. I'd look at a manual and I'd see 50. I'd look at the next manual, like Sam's manuals, it's 100. And then back and forth, and you look at a factory service manual from a radio manufacturer, they'd have a different spec, and it's like, oh my God. And then, you start working on ham radios, and, you're working on like a 6 meter or a 2 meter rig, and, well, it says 5 microvolts. What the hell? Well, that's because there's two different standards. If you're in the 6 meter band, that's 50 megahertz. If you're in the 2 meter band, that's 144 megahertz. So that would be this other chart where 5 microvolts into 50 ohms is S9. Or, I don't have it written on here, but like I say, that would be 10 microvolts EMF. But yeah, it can be very confusing, different standards for different frequencies, lots of different measurement types. So just be aware of that. The best thing to do is, if you're not sure, pull out your service manual. Like I say, some test equipment, the really high-end stuff, can do the output calibrated in any of the measurements. It can, like this. But other ones, like that signal generator there, it's just calibrated, well actually it's calibrated in microvolts and dBm. The knob actually is marked in dBm and microvolts. But that's nice because it's marked at 100 microvolts minus 73 dBm. So, that should tell you that you're actually, because minus 73, you would know that's actually, even though the dial says 100 microvolts, if it's actually 50 microvolts. So just be aware of that. I just can't overstate that enough. It's so important to read your manual. I know people are so used to nowadays just picking up stuff and going. The first thing that hits the trash can or the filing cabinet's the owner's manual, and people rarely read them. It's very important when it comes to equipment, because what scale or standard you're using can vary from equipment to equipment. So just be aware of that. And like I said, I hope that helps. Like I said, I know I've had a couple people over the years have sent me an email and asked me that. And I think I've shown the charts before, but I don't know if I ever covered the difference in dBm, dBu, microvolts EMF, microvolts in into 50 ohms, a lot of those different standards. So I hope that helps clear up some confusion. Hope I didn't make it worse. I don't want anybody to leave more confused than they came here, so I hope that helps.